Friends, let us now start with the IUPAC nomenclature of elements. But before starting with that, let us understand what was the requirement for IUPAC nomenclature of elements. You might ask, sir, what is the problem? If in case we, name elements, whoever has discovered the element can get the opportunity of naming the element. Like say, for example, if there is a scientist called as, there is a scientist of a particular country, and if in case he discovers, say, for example, iodine, let him give the name of that element as he feels like, or if in case there is an element, a radioactive element which is discovered with atomic number 992, then let that person who discovered that element, or let that country who discovered that element, put forward the name of the element which they propose, and let that be accepted. But there was proven to be a slight problem in this method. The problem was that in some situations there were simultaneously two different scientists belonging to two different opposing countries who had discovered the same element at around the same period of time. Due to which what happens is that both the countries were claiming the name and the credit for the new element which was discovered. The best example in case was element with atomic number 104, which which scientists from USA as well as scientists from the former Soviet Union, which is also called as the USSR Republic. So in the case of Soviet scientists and the scientists from USA, both of the groups, both of them had discovered the element which is rutherfordium approximately the same time. Scientists actually had a tendency during the Cold War of publishing or declaring the name of a new element which was discovered immediately without doing any further work or research on that element, which was not acceptable to IUPAC at that time. And that is the reason why, to ensure that there is no animosity which is generated between the two superpowers in the world having nuclear weapons, enough amount of nuclear weapons to wipe out the entire world many times over. They didn't want a world war and the human race to be finished just because of confusion on the on the exact date and the exact time on which of the group of scientists of different countries had come up with that new element. So what IUPAC had done is to diffuse that problem, and so that such a problem doesn't exist. Hence, for the elements which are present above 100, IUPAC has ensured that IUPAC nomenclature is used for giving the names of those elements. So in the case of atomic number 104, as we have already said, for example, the USA had given the name rutherfordium to that element. However, the Soviet scientists in USSR, they had for the same element which even they had discovered at around the same time, they had given the name of Kurchavotium. So again, there was this tension in the world because of these small things. So let us now look at how IUPAC had managed to solve this dispute and give its own nomenclature for any element, as a matter of fact. Not just element above 100, but you can use this IUPAC nomenclature to give the name for any element, even starting with hydrogen. But before understanding that, let us write down the basic terms which were used for different numbers. I mean to say, when we are talking about atomic numbers, each element has a different atomic number, right? So what was the basic name given to different numbers as we give in English, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In a similar way, what was the name which was given to each number from 1 to 10? Let us look at it. First, let us start with the number 0. In IUPAC nomenclature, the number 0 was given the name nil. In the case of the number 1, the name which was given was un, which is Spanish for 1. You might have heard the song Un, Dos, Tres, wherein like un is 1, dos is 2, and tres is 3. As of now, we are just considering the number 1, that name of un. Second, when we use the number 2 during the IUPAC nomenclature, its name should start with by. The number 3, then it will be obviously tri. The number 4, so instead of tetra or instead of fry, we will be writing it down as quadra or quad. Next, if in case the number, atomic number, it has the number 5 in it, in that case we have got to use the term pent. 6, then we have got to use the term hex. 7, in that case, instead of using the term hept, H-E-P-T, we should be using the term sept here. Next, if in case we have got the number 8 there, we write on the name as oct. If in case the number 9 exists, so therefore when we have the number 9 included in the name, then we will be having the name ENN, which will be included. We can also write down the abbreviations for the same. Like say for example, if in case we use copper, right? So the abbreviation for copper is Cu, the abbreviation for zinc is Zn, right? So in a similar way, we are right now going to write down the abbreviations for the same. So if in case we use the abbreviation, the abbreviation is simply the first alphabet of the name. So here obviously the abbreviation will be N, it is U, it is B, it is T, it is Q here, it is P, it is H, it is S, it is O, and then finally it is E. So these are the abbreviations which are used normally in small alphabets, not in caps. Here also I've written down in caps, but if in case this name comes in the middle part, the number comes in the middle part, in that case obviously we need to write this all these alphabets in smaller form and not in capital form. Once we understand this, let us now apply whatever we have learned and let us try to actually do the nomenclature of elements. So let us consider randomly any number like of elements. Let us consider first of all element with atomic number 100. Let us consider that, and then we will be writing down its corresponding name. So the element with atomic number 100 first we are going to do. Next, say for example element with atomic number 118. Next, say for example element with atomic number 104. Then say for example with 112. So in a similar way, here we are doing 4 examples, but again, my dear friends, we can do any number of examples which is possible. We can also write down the nomenclature for elements which are below 100, but as of now we will not be wasting time in that. So let us look at how to write down the nomenclature. So here we have 400. We know that we are going to start with un, right? Which un means basically 1. So here we will be starting its name by un. But after un we have 0, 0, right? So therefore we have un and then nil, nil. And then finally we have got to use the term IUM towards the end. Therefore here we have IUM. Next we have 118. So the element with atomic number 118 will be given the IUPAC nomenclature as follows. Again 1 will be, we know that it is un. Again 1 is un. 8 means oct. And finally we have IUM. So that these are the 2 parts of any of the names which are given in IUPAC nomenclature. So again the third element in this case having atomic number 104, let us see how we are going to give its name. So here we have again a 1 which is basically un. So the name of the element starts with un. We have again 0 which will be nil. And then we have 4 which will be quad. And then finally we have IUM. So these are the two parts of the complete IUPAC nomenclature. That is, this will be called as un nil quadium. This will be called as un octium. This will be called as un nil nilium. And this, in this case, we will be having again one will be un, again one will be un, and here two basically means by, and finally IUM. So with this, I hope so, my dear friends, that you've been able to understand how to write down the IUPAC nomenclature of any element in the periodic table starting from 1 to 118 or 119. So here I've just given some of the examples having atomic number above 100 so that you can understand how IUPAC nomenclature is used to prevent the different disputes between different scientists or different countries. Guys, let us now consider some of the exceptions that will be applicable whenever we are giving IUPAC nomenclature. So these are there will be two rules with the help of two examples which I am showing you here, which will be important for you guys to understand which mistakes to avoid when we are talking about exceptions in IUPAC nomenclatures. So here we have the element with atomic number 90. Which, say for example, if in case we want to give the IUPAC nomenclature of, let us see how we can give. Now in this specific case, we guys know that the element with atomic number 90 will have its name starting with ENN, right? So therefore its name will be starting with ENN. So it will be ENN, standing for 9, and after that 0, we know it is nil. So in such situation, we can write down the name as ENN, and then we can have it as NIL. Now this is a very awkward situation wherein we have 3 N's together in one name itself, right? And that is the reason why, to avoid such a situation, we will be removing one of the N's from here. So hence we, in such situations, instead of writing down ENN NIL, we will be writing down the name as EN. We will be removing one N out of ENN, and therefore after writing down EN, we are going to write down NIL. ENN, we will be having ENN and then IL. So this will be the first exception that we are going to write down. If in case we write down its abbreviation, that is its short form, then it can be written down in short as EN, because it starts with E and then the next part of the name starts with N. So I hope so, my dear friends, you have understood how to give abbreviation, the abbreviations. Abbreviations can be given very simply by simply just writing down the first alphabet which comes in any part of the name. So we have, say for example, if we have got 90, then there will be two parts to the name, right? One standing for 9 and other standing for 0. So in this situation, we will, once we have these two parts, there will be two alphabets which will be present in the name. Here there will be two alphabets, here there will be three alphabets. Each alphabet will be nothing but the first alphabet which comes in the term for each of these numbers. Again, here there will be three alphabets which will represent the abbreviation for that particular element. In the case of atomic number 83, we will be having its name written down, say for example, as 8 stands for oct, right? So oct will be the first part of the name, and then we will be having 3. 3 stands for tri, right? So tri will be the second part of the name, and finally we know that we need to write it down as EM. So therefore finally we will be having the name written as IUM. Now the same thing obviously will be applicable in the case of 90 also. So here also we will be writing down ENN, NIL, and finally we need to write down EM. So again, this name will have 3 different parts, the final part being constant for all the names. Now here in this case also we have this as a second exception, that is any IUPAC name wherein we have here the number 3 or the number 2 which with which it finishes, in that case we remove one I out of that name. So therefore here we have a situation wherein we write down the name as oct, then we have try, right? And out of this tri, we remove this I, that is the entire point. We remove that one I, and then finally we write down IUM. So this is this will be in this particular case the name will be O and then T. In the next case, this will be 105. In this situation, let us look at what the name will be. If in case we look at the name here, it will be 1 stands for un, and 0 stands for nil, and then 5 stands for pent, and then finally IUM. So therefore we have the first part of the name, second part of the name, third part of the name, fourth part of the name. Fourth part of the name obviously being constant for all the elements. In this case, there will be no exception in this specific case. This was just a general example. Just quickly, let's write down the representation which will be used in this specific case. The abbreviation which will be used will be U, and then N stands for nil, and P, which will be the first alphabet of pent. So it will be UNP. In the case of the last situation, let us consider that the last element has an atomic number of say 119. In this case, we'll be having the element which will be named as un, and then 9 will be nothing but ENN, and then finally IUM. So here we have first part of the name, second part of the name, third part of the name, fourth part of the name. Here the abbreviation will be given as follows. Here it will be starting with U, and then it will be starting with U, and then it will be starting with E. So this will be the abbreviation which will be applicable. Finally, let us take one example wherein the atomic number finishes with 2. In this situation, if in case we consider, here we will be having the atomic number as say for example 112. Let us look at how we can do. We guys know that from our experience that in the case of try and as well as in the case of by, we are going to remove one I out of the name, right? So let us in this case write down the final name at one go instead of wasting time in writing down the incorrect name. So therefore the correct name in this specific case will be un, standing for 1, then un standing for this one, and then finally by standing for the term 2. And then finally we will be having IUM which will be put, and hence here we need to remove I from by as the rule as I told you suggests. So here we will be having only B, and then finally you will be having IUM. So these will be the 4 parts of the name. Here the short form can be given as U, which is the first alphabet of this first part, U which is the second part alphabet, which is the first alphabet of the second part, then B which is the first alphabet of the third part. So finally we don't represent IUM in inside the name. So I hope so, my dear friends, you have understood how to write down the abbreviations, and also you have understood the exceptions which will be applicable in the case of IUPAC nomenclature. So don't make any silly mistake regarding this.